Hello, MechanoTherapy patients. Warren Hebert here. I wanted to do a quick talk before I take off for Thanksgiving break. Happy Thanksgiving, everyone. This is a talk that I give so often. I've been meaning to record it for quite a long time. And I have a patient who just started up with PT recently, and he asked me a really good question, a smart guy who's really involved with his care. And I said, I think this is the point where I just need to record this so that you guys can have it available to you and any family or friends who you think would get value from it. And the question is, this gentleman has chronic hip pain, and I've seen him for 2 visits, and he sent me an email asking a really good question. Hey, I've got anxiety and depression, and I found these articles, peer-reviewed studies that say anxiety and fear, avoidance, and things like that can intensify the duration of symptoms for something like hip impingement, and it also seems to have a negative. People who go into surgery for hip impingement seem to have worse outcomes on the back end if they go into surgery with anxiety and depression. And my answer is anxiety and depression absolutely play a huge role in the processing of pain, but it's not unique to the hip. It's actually been studied all over the body, and it continues to be true. So my hope today is to share a little bit about the mechanism of why that happens, and to kind of understand, if there's a take-home message today, it's pain is multifactorial, and it's not just tissue damage, and pain is actually an output from the brain that takes a lot of things into consideration. So here we go. This framework, I will say, I'll be the first to admit, is not comprehensive. Like, if you were to talk about this with a pain research expert like Mick Thacker over in Europe, he'd probably scoff at the simplicity of it, but it offers a framework for people to understand that there's a lot going on when it comes to pain, and also give you kind of an idea of how we approach things here. So I tell everybody, every pain that you have is a nerve pain. Something as simple as a muscular tear or muscle injury, the input and output all has to do with the nervous system as far as what we feel. So let's do a little imaginary scenario here where this gentleman here has some knee pain. So in the knee, we have nerve endings, and essentially these nerve endings respond to different things. Some respond to mechanical pressure, some respond to tensile load, and some respond to chemical changes. And then that's kind of where inflammation takes hold of us, is because inflammation is essentially a chemical change in the surrounding tissue around a nerve ending. Whether it's mechanical pressure, mechanical tension, chemical changes in the area, all of these nerve endings have a threshold, and once that threshold is reached, they send a signal up the leg, in this case, to the spinal cord. So arbitrarily, let's say at the knee, there was a nerve ending that could handle 100 pounds of compression, but because of a sudden increase in running volume or something like that, we developed a little bit of inflammation in the tissues around the knee, and so now those nerve endings are changing their threshold. They say, we were able to take 100 pounds of compression, but what we're going to do now is lower that down to 80, so that you feel anything over 80 pounds to kind of protect you from ongoing irritation and inflammation. All right, so this incoming pain signal, I shouldn't even use the word pain, it's not pain yet, it's just a signal of irritation. So we've got an incoming signal of irritation. That term is nociception. We've got incoming nociception, a signal delivered to the spinal cord. Once it gets to the spinal cord, things get really interesting. We have this little entrance portal for the signal. It's called the dorsal root ganglion, and that's essentially what I refer to as like the processing chip of the spinal cord for pain. And the dorsal root ganglion is really, really fascinating, and it has the capability to process that incoming signal and either turn it up or turn it down, just like the volume on your stereo. And it's a completely subconscious thing, and it largely revolves around the state of health of our general nervous system and well-being. And I like people to think of this as a seesaw between the two dominant neurotransmitters of the spinal cord and brain, and that's GABA and glutamate. GABA is the feel-good, relaxing neurotransmitter for people who do indulge in the occasional beverage. It's actually the receptors that act on our brain when we have a drink of alcohol. It's very calming, relaxing. Glutamate is the exact opposite. Glutamate levels go up in almost every medical condition that you don't want to have. They're high levels of glutamate are present in the central nervous system when it comes to anxiety, when it comes to depression, and bad things too. Other medical conditions that we don't need to get into today. But glutamate, once it gets past a certain level, is never good. So the things that influence that seesaw relationship between GABA and glutamate have a lot to do with general health behaviors. Chronic stress, poor sleep, anxiety, previous history of pain in the area, that's probably more in the brain that we're talking about, but general health behaviors, health like nutrition, all those things affect the balance between GABA and glutamate. And all of the things that I mentioned, like poor sleep, lack of sleep quantity or sleep quality, a lot of anxiety, stress, all of those things, if they occur chronically, tend to drive glutamate up and GABA down. Unfortunately, what that means for this incoming pain signal is that if we have a general health state where our anxiety, stress, all these things aren't going well for us and our glutamate levels are higher, it'll actually increase the volume on that incoming nociceptive or irritation signal. Then it transfers that signal up to the brain, where we has lots and lots of the processing chips, and it gets a lot more complicated. But it's a similar process that occurs into the brain. Takes into account a lot of social and contextual factors. The one that gets talked about the most is low back pain, because low back pain is probably the most studied, but also just a huge problem for the entire country, the entire world when it comes to healthcare costs and stuff like that. There was a lot of fear and avoidance historically that's been injected into the culture of back pain. Bed rest used to be a huge thing of the past, anything we could do to avoid the behaviors, but the more we learn about back pain, we know that it's important to keep people moving and decrease fear avoidance as little as possible, because the more we fear the things that are going on, the more anxiety and stress that we develop, the worse our sleep becomes. All of these things have the ability to chronically drive that glutamate GABA relationship, and frankly just kind of sensitize the whole system, whether it's the peripheral nerve endings at the site of tissue irritation, or not even tissue irritation, or the central nervous system in the brain and the spinal cord. So hopefully that gives some insight into how pain is multifactorial. It's not always just tissue damage at the site of pain. The pain we experience is an output out of the brain after those signals have been processed, and our current health state is totally relevant for what we're experiencing. Two people can have the exact same amount of tissue damage, whether it's from a hamstring strain, patellofemoral pain syndrome, hip impingement, you name it, but have totally, completely different experiences depending on the general health of their nervous system. Sometimes these things can be obvious, and patients are well aware that they have these things going on, and it's absolutely of benefit to address these things with the help of a professional, whether it's a counselor, psychologist, psychiatrist, those kinds of things. But it's not always necessary either. Sometimes they can be subclinical issues where exercise, for example, I believe there's studies showing that one session of yoga and movement can increase GABA levels in the nervous system by 20%. There's a lot of people who I've treated who have had some level of dysfunction when it comes to this stuff, but by increasing the activity level, increasing quality of life, they can kind of get over it. So hopefully that wasn't too much word vomit. Hopefully it was helpful. If you have any questions, feel free to reach out.